All right, okay, I've got a thumbtack and I've got a string attached to a weight. So what I'm gonna do is take my little flower and I'm gonna randomly stab it somewhere. Let's put it right here. So I've got it stabbed and all I'm gonna do is move it upward and hang it. So let me actually put the iPad up a little bit further so you can watch it hang. Let's put it up like this. Uh-oh, I don't want it to fall off. That would be disastrous. Okay, I think you can still see it, and here comes. Okay, it sort of looks like a marijuana plant, but think of it as a lotus plant. So do you see how it's freely moving around, and what happens is that this thing kind of will move around until it will stop of its own accord because of gravity. It wants the torques to be equal to zero. The torques have to be equal and opposite. So notice how it hangs at a certain distance. So what I'm going to do is capture that. I'm going to draw a line on my lotus flower like this. So at that particular suspension point, see where my line is? It hangs directly downward. Now the center of mass must be somewhere along that line. To figure out where it is, I just pick a different random spot. All right, I'll pick this leaf on the lotus flower. And of course it hangs differently. And I let it kind of freely swing until it stops. Okay, it's not quite freely swinging. There it goes. So I'm going to capture it again and draw that line. So now I found my center of mass where the two lines meet. And just to check, oops, let's go pick one more point on here. Let me pick on the stem, or pick the stem right here. And again, I will suspend it. You can see that the line goes really close to my first two intersections. In fact, if I try and capture it, it's like almost directly there. So my center of mass is going to be right where all the three lines intersect. Now this is where I don't know if you can see that little dot, this is where I estimated it to be, so I was off a little bit. It is actually down there, but that's the center of mass of my object. So it's pretty easy to find one. And the reason why it moves and it stops is because it's balancing. When it's balanced, the torques on either side are equal and opposite. That means the torque pulling it to rotating this way is equal and opposite to the torque rotating it this way. So all the mass that's being pulled on this side will be equal and opposite the force on the other side. So what we're going to do now is set up another way to measure torque, and that's through irregular balance.